law of sines. Officially adding another set of, I don't know what, it's not identities, it's a law, it's law of sines, okay? But adding another set of rules, so to speak. We're going to talk about triangles in these next two lessons because we have law of sines and then it'll be law of cosines after spring break. But how this reads, in any triangle ABC, so we're not talking right triangles, just in general triangles, non-right triangles, with angles A, B, and C, realize that angles are usually denoted with capital letters, and opposite sides A, B, C, so lowercase are your lengths of sides, respectively, the following equation is true. So this is saying the sine of angle A is proportional to side A, just as the sine of angle B is proportional to side B, just as the sine of angle C is proportional to side C. So the sine of the angle and its respective side are proportional in all these pieces. And the idea is that you're not going to use three pieces at once, but depending on what information you're given, you can take two of these three pieces at a time and set up an equation. So the idea is if we know, say, angle A and angle B, and we know side A, and we want to find side B, then we could take this first two pieces, set it up as an equation, and solve it. Okay? So it gives us a way, as long as we know enough information, to find missing sides and missing angles on a triangle. Okay? Now, in geometry, you had acronyms. AAS, ASA, SAS, SSS. You remember some of those? Okay. And at the time, you used them to talk about whether triangles were congruent or similar or whatever portion of geometry you're in. Okay. Well, these apply to law of sines and law of cosines as well. Okay. In addition to what you did in geometry, you also get to use angle, 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 which you didn't get to use in geometry, and side, side angle. Okay, those are two that didn't apply in geometry, but they will apply in situations now. Now, specifically, we're talking law of sines today, right? Law of sines has three. Angle, angle, side, angle, and side, side angle are the three that apply for law of sines. So I know I just mentioned all of those. They don't all work for law of sines. But triangles where we are given two angles followed by a side, an angle with a side and an angle following it, or two sides followed by an angle, law of sines will work. And as long as we're given those three pieces of information, we can find all the missing sides and angles. Okay? So, example 1. Okay? And here we're going to solve triangles with angle, angle, side, and angle, side, angle setup. With these two setups, you will always get a unique solution. So there's one and only one solution. Okay? And that is basically anytime you are given two angles. Okay? So our two options that include two angles. So it's asking us to solve triangle ABC, given that angle A is 36 degrees, angle B is 48 degrees, and side A is 8, has a length of 8. Now, when they say solve the triangle, they're saying find all the other missing pieces. So in this case, I was given two angles. I have to find the third angle. I was given one side. I have to find two other sides. Now, if you look at this one, what were we given? And I'm going to use this up here for reference. We were given what? Angle A, angle B, and side A, yes? So what do we have there? We have an angle, followed by the next angle, followed by the side. So this right here is an example of angle, angle, side is our provided information, which means we can use law of sines. Okay? So I'm going to write down kind of what we have and what we need to find. We know angle A is 36 degrees. We know angle B is 48 degrees. That means we're going to need to find angle C, correct? And then we know side A is 8, and that means we need to find side B and side C. Now, I'm going to claim one of these pieces of information we can find is old news.
Angle C.
How can we find angle C?
Subtracting that by 180.
Okay. All three angles in a triangle always add up to be 180, yes? So the idea that angle A plus angle B plus angle C adds up to be 180 degrees. So we know in our situation, 36 degrees plus 48 degrees plus angle C is equal to 180 degrees. You guys do the math and tell me what angle C is. $96. Okay, so I got angle C. Next. And it's not that you had to find angle C first, it was just the obvious piece, right? Get it out of the way. If you look at what we were provided originally, okay? Originally we were provided angle A and side A, yes? Anytime you're provided a set, so A with A, that is a set we can use to help find other pieces. So I have a matching pair, so to speak. I don't know what you want to call it, but I have my A's. That means if I have my A's and I know angle B, I can find side B. Okay? And we can do that using these first two pieces of our law of sines. So I'm going to set up the idea of sine of angle A over side A is equal to sine of angle B over side B. Fill in what you can. So sine of, what are we saying? Angle A is 36. So sine of 36 degrees divided by side A, which is 8, is going to be equal to sine B. Sine of 48 degrees divided by side B, which is what I'm trying to find. Okay, now keeping in mind, sine of 36 degrees, sine of 48 degrees. Those are numbers, yes? I don't know what they are until I plug them in my calculator, but they're numbers, okay? My job is to solve for B. How do I solve for side B here? What are you plugging in?
Well, divide sine 36 by 8, and what you get there is 137.
Not exactly. If I go back to what you probably learned in middle school at one point, I have a fraction equal to a fraction, yes? What's my shortcut I can use when I have a fraction equal to a fraction? Cross products? Okay. I mean, it's also the same as just clearing your fractions out and multiplying both sides by 8 and b. But the shortcut we usually use is cross products, where diagonals, b times sine of 36 is going to be equal to 8 times sine of 48 degrees. What do I have to do to solve for b?
To divide by sine 36.
Right? So I'm going to take 8 times sine of 48 degrees and divide by sine of 36, because it's b times sine of 36, so we're going to divide. So I know b is going to be equal to whatever 8 times sine of 48 degrees divided by sine of 36 degrees is. know that's what I'm looking for right now. I have 2 decimal places. Now, I would encourage everyone to try this and make sure we all get 10.11. Why might you not get 10.11? In the wrong mode? We're entering degrees, yes? So you need to make sure that you are in degree mode. So that is, and that's going to be this whole entire lesson. We're not going to be switching back and forth. We're using degrees here, okay? Because you don't talk about the angles of a triangle having radian modes. So if you're not getting 10.11, then check your mode. Either that or you just entered something wrong. So approximately 10.11. Okay. Okay, that's how your law of sines works. How can I use law of sines to find side C, my last missing piece? I would prefer you use A. And why am I going to say I prefer you use A? Okay, so B, couple of things. Could you have made a mistake on side B? You could. B is also side B is a rounded value. And anytime you use a rounded value, you're losing accuracy. Now, do you have to use rounded values sometimes? Sometimes. But if you can avoid it, avoid it. So, yes, I would set this up. I would go back and use sine of A over side A. And then this time, sine of C over side C. Okay, so just pick the 2 pieces you need. So sine of, what was A? 36 degrees over 8 is equal to sine of 96 degrees over C. Same idea? Okay. Basically, it's cross products is what I think of it. It's also multiplying both sides by 8C. If on the left you multiply by 8C, the 8's cancel. You're going to have C times sine of 36 degrees. If on the right you multiply by 8C, the C's cancel. You have 8 times sine of 96. In order to get C by itself, since it's C times the sine of 36, you're going to divide. So you're going to have 8 times sine of 96 divided by sine of 36. And again, I have my answer to 2 decimal places. And you guys got what? There you go. Hello. Nope, 3rd hour. Nope, no problem. Bye. Okay, what did we say it was? Okay. 13 and 54/100ths. Okay. Got the basics? Okay. So this is a situation where we were given 2 angles, and we're able to find the missing angle and the missing 2 sides. Okay. Yeah. Doing the math. Okay. Now, let's look at some other situations. Okay. So the situation that gets a little tricky is what they call the ambiguous case. And so this is your side-side angle case. So where they give you 2 sides followed by an angle right after those 2 sides. And it's the ambiguous case because it kind of depends on how the pieces of information are related to each other as to how many triangles there's going to be. Okay? Whether there are 1, 2, or no triangles possible. Okay, so again, it all depends on the information they give you. So we may have 1 triangle, 2 triangles, or no triangles possible in some of these cases. Now, I have an attempt to write it out here, summarize it. The best thing is going to be going through and looking at some examples. But for instance, if angle A is obtuse, okay, and this is just, obviously this picture would not be drawn to scale for angle A, but if angle A is obtuse, then there is one triangle possible as long as the side opposite it is bigger than the other side given. Okay, and that comes down to if you have an obtuse triangle or an obtuse angle would be the largest angle in the triangle, and the largest side has to be across from the largest angle. Okay, and so thus there would be no triangles if the reverse was true, where C was greater than A. Okay, in other words, if A is not the largest side across from the largest angle, then it's not possible. So that's one scenario we'll deal with. Okay. If A is instead acute, okay, so now just a traditional acute triangle, then there are two possible triangles if C is bigger than A. Okay, so if the adjacent side is bigger than the side across from it. One situation where angle C is obtuse, and one situation where C is acute. And we will look at one of those examples. Okay? That's the one that gets a little confusing, is when you can have two triangles, is getting both situations. And then if angle A is acute, we have one triangle possible if the side across from it given is bigger than the side next to it. Okay, so kind of the reverse of this situation here. Now, it'll come down to being able to look at the information and figure out what's going on. Sketching a triangle is sometimes helpful too. Okay, and that's kind of what the part of the way I'm going to take you through it. Sometimes it's how do we know how to draw the triangle, but there's not just one right way there. So, I think I have examples A, B, and C with this. Yes. So, we're going to solve triangle ABC. And as it says, the best way to determine which type of scenario is to kind of sketch a triangle or use this setup here. So, given that side A is 7, side B is 6, and angle A is 26.3 degrees. Now, I'm going to try and, let's see. I'm going to put my side, gosh darn it, my angle A, okay, I'm just drawing a triangle right here. I'm going to put angle A in that left corner because that's where I like to kind of put this angle I know. I'm going to go B, C, and that means we have side A across from A, side B across from B, side C across from C. If we fill in what we know, so what do we know here? Side A is 7. Side B is 6. And angle A is 26.3 degrees. Now, as you look at this, keep in mind, this example up here where I tried to go through the possible options, I happen to use A and C. Is it always going to be A and C? No. A and C were just representative of an example. In this case, we're talking about A and B. But here's the deal. This given angle is what? This given angle is acute. And what do we know? The angle across, or the side across from it, is greater than the other given side. So we're looking at this bottom scenario here. Okay, where it, in this case it was A is greater than C, in this case we're given B. So how many triangles are supposed to be possible? Just one. We're starting off basic here. Okay, nothing fancy. So with that in mind, what could we start off finding? Well, hold on, I was going to write, can we agree that this is side-side angle?
Yeah.
Side-side angle? Okay. Uh-huh. Okay. And I'm going to write down here that angle A is acute. And what do we say? Side A was bigger than side B. That's kind of our reasoning information of we're just looking at one triangle, nothing fancy. Okay. We have our pair of information. We have our A's, right? Big A and little a. And then we have B. So if we have our pair of A's and we have B, that means we can now find our other B information. So I'm going to set it up as the sine of angle A over side A is equal to the sine of angle B over side B. And you don't necessarily have to write this initial setup I am. It's just helpful in my mind. So sine of A is going to be what? Sine of 26.3 degrees divided by side A, which is 7, equals sine of B, and guess what? B is what I don't know, divided by side B, which is 6. Okay. The difference about this problem? We're trying to find an angle instead of a side, yes? Okay. Normal next step. What's our normal next step? Okay, cross products. Basically get rid of those denominators. So I can say 6 times sine of 26.3 and 7 times sine of B, which I'm actually going to write that one first. 7 times the sine of B is equal to 6 times the sine of 26.3 degrees. Okay. What do I do next? Divide by 7, yes. We can't get B by itself quite yet, but get sine of B by itself. So if I get sine of B by itself, I'm going to divide by 7. So sine of angle B is equal to 6 times sine of 26.3 degrees divided by 7. Now, and eventually, you guys know I'm going to plug this all into the calculator, yes? I'm just waiting until the right moment. How do I find angle B? Because in this situation, B is my input to sine, and I don't know it. And my output is that fraction. So I don't know my input, but I do know my output. What allows me to switch those? What allows me to switch my input and output? No? It's not your reciprocal function, which is where you're trying to go. What allows us to take our input and our output and switch them? That's using what kind of function? Inverse? Yeah. Okay. So remember, if you have your input and your output, so in this case, my input is B, my output is that fraction that I don't know the value of yet. If I want to switch those pieces, we use the inverse function. So in other words, what we're going to do is we're going to switch basically B and this fraction. And then instead of saying sine, though, we're going to say sine inverse. Okay, so in order to do this, I'm going to write this as B, big B, is equal to sine inverse of this fraction, 6 sine 26.3 degrees over 7. Okay, remember we did inverses. It's been a minute, right? But we did them. So you're going to do, in order to do sine inverse, that's going to switch my input and output. So B in the fraction switch sides, it becomes sine inverse. How do we do this on the calculator? Sine inverse is the one that is the second function, right? So you're going to do second of the sine button. Type that whole lovely little fraction in. And we're going to get an answer.
22.32.
Yes.
Okay.
I'm laughing at myself because Okay. The rest of the homework, the rest of the notes, I just have 1 decimal place. Why did I do 2 on the first one? And now I have 1.
I kind of like to do that.
I don't care what you write. I have 22.3 written in my notes. So that was equivalent to what you said, right?
Yeah.
Obviously, I had a moment of not staying consistent. Now, are we getting the calculators to work? I didn't put mine up on the screen. I 100% encourage you to try this, yes?
Yeah.
Don't wait until it's too late. And it's big B. I just threw an angle sign in front of it just to kind of differentiate. Okay. So we found angle B. That's the hardest part of the problem.
Oh, is it?
Yep.
Maybe I'm just.
To me, that's the hardest part of the problem. We can go
Oh, because.
one of 2 ways next. Actually, no, we have to go 1 way. Okay, can we find angle C with the fact that all 3 angles in a triangle add up to be 180? Yeah, and you're going to have to do that before you can find side C. Okay, I'm actually going to throw that over under here where I have a little extra space. I'm going to need this other space. So back to the fact of angle A plus angle B plus angle C equals 180 degrees. So 26.3 degrees plus 22.3 degrees plus angle C equals 180. And you're telling me that angle C is 131 4/10 degrees. Okay. Now we've got angle C. I'm assuming you guys were okay with angle C.
Yeah.
What do we have left to find?
Well, we did side C.
Side C. How do we set up to find side C?
Sine A over side A equals to sine angle C over side C.
Okay, exactly. Now, and again, could you use the B information?
Yeah.
You could. My preference would be that we use the A information because we are given the A values, they're not rounded. Most of the time it's not going to matter, but on the occasion a rounding situation throws something off, just trying to prevent that issue. So sine of A over A equals sine of C over C. So sine of 26.3 degrees over side A, which is 7, equals to sine of 131.4 degrees over side C. Are we becoming pros at solving this?
Yes.
Okay. And I have to have this set up, folks, right? I have to have this set up. Do you have to show exactly all the steps I'm showing? Not necessarily, okay? A little bit of steps, though, is helpful in terms of we don't want to make careless mistakes or, that way I can see a careless mistake on the test. So cross products are, C times the sine of 26.3 degrees equals 7 times the sine of 131.4 degrees. Divide to find C. So 7 times sine of 131.4 degrees divided by sine of 26.3 degrees. And again, make sure you've at least practiced some of plugging these values into your calculator with me today. What are you getting? Okay, and I have mine as 1 decimal place, so I have 11.9. I really need to go back and just change that first example to 1 decimal place since all my others are that way, but okay. So this example, again, not too bad of an example. This also gave us the experience of how do we find the angle, right? So that always, in order to find your angle, you're always going to have to throw in that sine inverse. Okay. Got it? Okay. Moving to the top of the next page. Now, B and C still fall into the scenarios that we were just given here. Okay, so we're still talking side-side angle. Now, it might give you a hint because I went ahead and just pasted some triangles in for us on this one because I retyped the notes this year, and every year I stink at drawing these triangles and making them accurate. So guess what? I stole the images from the book, and we're going to use those. Okay? Makes it a little less, it's more obvious, but so solve triangle ABC. Given that, what do we have here? Side A is 6, side B is 7, and angle A is 30 degrees. Okay, that's the given information. Now, notice that we are definitely still in a side-side angle situation, yes? Now, what do we notice in this case? The side opposite, A, is less than the other given side. And if you go back real quick to the front, A is acute, and the given side A is less than the other side. Then now we have two possible triangles.
What?
Okay. We have two triangles possible. Now, you see I've drawn two here. Okay. The first scenario is this triangle right here. Where you have triangle ABC, and where C, is that obtuse there? I think that must be obtuse. Where C is an obtuse angle. Does it work out to be? Yeah. Okay. You also have the situation, and here's the second example, okay, where you still have your 30, your 7, your 6, but the idea is now this triangle, because this side 6 is smaller than side 7, this side that was out here, so realize this 6 is the side that was out here, yes? Because that 6 is smaller than the 7, we also have the option where that 6 could swing under, and now C is, instead of being an obtuse angle, it is a very tiny, very acute angle, okay? So these are the two scenarios you run into when, in this case, it was, what? A is less than B. Okay, those are the two scenarios you run into. Now, two separate scenarios. Do your first traditional triangle, and then we'll use some of that information to find our second, less traditional triangle, if you will. So, where can we start on the first triangle that I traced in purple? Where do you want to start? Yeah, which, here, I'll put, what is, this is side A, this is side B, yes? We have angle A, side B, that means we can find angle B. Okay? So, and realize, guys, I'm squeezing information in here, yes? Okay, I don't know, maybe I should have just sucked it up and gone a whole nother page of notes, but I didn't.
Wait, do we have to find? Oh goodness.
Okay, so here we're looking at sine of A over side A, sine of B over side B. So sine of 30 over 6 equals sine of B over 7. So basically I'm going to try and use the top half of this area for the first triangle, the bottom half, I'm going to save the bottom half for the second. Okay? Now, what can we do here? Cross multiply, yes. And if you let me be kind of fancy, we can cross multiply. And at the same time, so that's going to be 6 times sine B equals 7 times sine 30. Could I go ahead and divide by the 6 also? Are you guys getting this enough that I can say sine of B is equal to 7 times sine 30? and then divided by 6. I'm going to bring this up here a little bit. How do I actually find b then? Yeah, we're going to do sine inverse of that lovely fun fraction, right?
Yeah.
7 sine 30 over 6. And that will give you angle B. I have 1 decimal place.
35.7.
And that is 35.7 degrees. Okay. I guess we'll stop in that awkward spot. Remind me tomorrow where we've stopped. And we'll pick up tomorrow.
Did we do any homework yet?